This is Mr. Hardesty. In our next example, we'll graph a quadratic function. Consider the quadratic function f of x equals 6 plus 5x minus x squared. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Then make a table of values that includes the vertex and graph the function. Our original function for this quadratic will be easier to understand if we start by putting it in descending order. So we're going to rewrite with the largest exponent first. And I will change this to f of x equals negative x squared, then plus 5x, and then the constant plus 6. We're to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. The y-intercept is 6. That's the c value on the end, so the y-intercept is 6. Now for the axis of symmetry and the x-coordinate of the vertex, we have this formula that x will equal the opposite of b over 2a. So we can substitute from our function, and we'll write x equals, the opposite of b will be negative 5 over 2 times a, which is 2 times negative 1. Here's a, the assumed negative 1 out front. We'll simplify, and we'll get 5 over 2, which is the same as 2.5, or 2 5/10. This means our axis of symmetry is x equals 5 halves, and it also means that the x-coordinate of the vertex is the same, 5 halves. Now we'll make our table of values so that we can graph the function. Let's pick 0, and we've actually done this one because when we put in 0 and simplify, we will have the y-intercept. This is 0 plus 6, which is 6. So our first ordered pair is 0, 6, which is our y-intercept. Let's choose 1 for x. We'll substitute 1 into our function. And when we simplify with 1, the result is 10. So our next ordered pair is 1, 10. Let's pick 2.5 or 2.5. That's an important point since it's the x value of our vertex. So we'll substitute 2 5/10 in, and when we simplify that, we have 12 25/100. So this is where our vertex will be on our curve. 2 5/10 and 12 25/100. Let's choose 4 for another ordered pair. It goes in for x, and we simplify and get 10. 4, 10, another ordered pair, and finally we'll choose 5. 5 into the function, the result is 6. So the ordered pair, 5, 6. To graph the function, we need to place our ordered pairs on our graph. From the size of some of our points, I'm going to count intervals of 2. From the origin, we'll go 2, 4, 6, and so on. And we'll do the same thing for the y-axis, intervals of 2. Now we'll place our points. Let's start with the vertex here in the middle. We have 2 5/10 and 12 25/100, so about there. Our vertex V. Now, 110 and 410. That is 110 here and 410 here. Note the symmetry between those 2 points. And the same with 0, 6, and 5, 6. 0, 6, and 5, 6. We'll draw the smoothest curve we can, connecting those points, and we'll have graphed our function 6 plus 5x minus x squared.